guys, welcome back to my channel. Today I'm going to be talking about linear differential equations. So with these linear differential equations, they typically have the form dy over dx plus p of x times y equals to q of x. So here p of x represents some sort of x term, right? And there's a y here, and then this is a derivative of the y, right? And then here's some sort of x term right here for q of x. With these equations, the trick to solving these equations is basically to multiply by an integrating factor. And the integrating factor looks something like this. It's represented by I of x, and basically it's e to the exponent of the integral of p of x. And p of x comes from here. So I'm going to be illustrating this with an example to show how we can solve linear differential equations. Say we have an example that looks something like this. 3x times y prime minus y is equal to 7x cubed. So in this case, we can see that, well, we have y prime, right? Y prime is the same as dy over dx, okay? So this kind of matches up, these two. And we have a y here, so these two kind of match up. But then here's the issue. Well, this is y prime, right? This is dy over dx, same as y prime. Well, there's nothing beside it in this form, right? But however, here is something beside it, which is the 3x. So we're going to have to get rid of this 3x. We want to get this equation into this format, right? So that's what we're going to do. So we're going to divide all the terms by 3x. So dividing all the terms by 3x, we get this. We get the following. Well, if we divide by 3x here, it's just going to cancel out. Here we divide by 3x. Dividing by 3x, we can see that we will get y prime minus y over 3x is equal to, well, if we subtract these exponents, right, this is exponent of 1, it's going to be 7 over 3x squared. Just like that. And then now we can see that, oh, well, now our y prime is matched up perfectly. There's no other terms beside it. And then now let's write this a little bit better so we can kind of see what our p of x is, right? Because p of x has to be some sort of x terms. So we will write that. So here, let's separate this 1 over 3x times y, right? So we can separate, and we now see our y here, and this here is our p of x. Make sure you include this negative sign as well, because here it's positive, right? So we're adding the negative, so this whole thing, including the negative, is our p of x, and then here it's 7 over 3x squared, and this whole thing here represents our q of x. So there we have it. We have the equation of this form, and now what we have to do next is, we see our p of x, right? We have to find our integrating factor, and that we can multiply on both sides of the equation. So to get our integrating factor, let's first find this exponent part. So the integral of p of x. So to do that, the integral of p of x, is going to be equal to the integral of negative 1 over 3x, because this here is our p of x, right? Our p of x is equal to negative 1 over 3x. So we're going to have to take this and we're going to have to put it in our integral here. So negative 1 over 3x, just like that, dx. And then now what we do is we can see, oh, this is a constant. Negative 1 over 3 is a constant. You can bring it out of the integral, right? So bring it out. We will be left with 1 over x dx, just like that. And then we can see here, oh, well, the integral of 1 over x is going to be, what's it going to be? It's going to be ln the absolute value of x, just like that. And then we have to add a constant, right? But we're not going to actually write in the constant when we put this into our integrating factor. There's going to be no constant in there. So we're not going to write the constant when we put it into the integrating factor, but technically there should be a constant, but when we write it in here, we do not write the constant. So our integrating factor is going to be equal to e to the exponent of this, what we just found, right? Negative 1 over 3 ln absolute value of x. And then now let's kind of manipulate this. Let's rewrite this as e to the exponent of ln absolute value of x all to the exponent of -1/3, right? Exponent laws, right? You can multiply these two exponents together, you're gonna get this, right? So that's why we did that. And then we use this little trick here, right? Basically, if we have e to the exponent ln of a, this is going to be just equal to a, right? If it's just going to be equal to a here, well, we can apply this here, right? This we can apply here. So to apply this here, we are going to get a, and our a in this case, right, ln x, well here, our a is going to be the absolute value of x. So this whole thing, this in the brackets, is just going to become absolute value of x. Just like this. We just copied this -1/3, right? Copy it. And then this is just going to be, we remove the brackets. It's going to be absolute value of x like that. And then it's going to be 1 over absolute value of x to the exponent of 1/3. Now we got this part, and we can see that this is an absolute value, right? We can see that for our absolute value, right, of x, it's going to be equal to either x or -x, right? And it's going to be equal to x if x is greater than 0, and it's going to be equal to -x if x is less than 0. So in this case here, we are going to have to consider both cases. So this is going to be equal to two different things, and these two different things are either 1 over x to the exponent of 1/3, or this can be 1 over -x to the exponent of 1/3. So there's going to be two cases here, and here we can see that, oh, well, we have, if we were to simplify this negative part, so if we were to simplify this, we are going to get the following. We are going to get, well, we can rewrite this first, right? -1 times x, right? To the exponent of 1/3, just like that. And we can apply this exponent to each one. So we apply this exponent to each one of them using exponent rules. And then once we applied it to each one, right, you see the -1 to the exponent of 1/3. Well, we know that -1 times -1 times -1 is going to give us -1, right? That's saying -1 cubed gives us -1. So the cube root, right, which is -1 to the exponent of 1/3, right? Cube root of this is just basically this. And so we basically get, well, if it's this, then cube root of this, well, if three of them multiply together get -1, right? Then the cube root is just going to be -1. So this whole thing hence is equal to -1. So here, this will be -1 times x to the exponent of 1/3, which basically simplifies to -1 over x to the exponent of 1/3. So we have either this or this as our integrating factor. So previously we had this equation, right? We basically made it into that linear differential equation type of format, and then we also found the integrating factor, and the two cases, right? The two cases, the integrating factor can be equal to 1 over x to the exponent of 1/3, or it could be equal to -1 over x to the exponent of 1/3. Okay, so we have two cases. Now let's consider both cases. So case 1 is if it's equal to this one, right? So case 1, so let's do case 1. If I of x equals 1 over x to the exponent of 1/3. So if we use case 1, well, remember we have to multiply both sides by the integrating factor after we have this equation in this form, right? And after we have found the integrating factor. So we're going to multiply both sides by this. So basically it's like multiplying all the terms by the integrating factor, like multiplying by the integrating factor here, right? This whole thing, and this whole thing by the integrating factor. So if we multiply the whole thing, we're going to, let's say this was our integrating factor, considering the first case, we are going to get, well, we're going to multiply all the terms, so we're going to get the following. Just copying these, and then times the integrating factor. And this is going to be equal to 7 over 3 x squared times our integrating factor. So now we are going to simplify this, so let's write this as a negative exponent. Perhaps I will show you why later on, but there is a good reason to. So the negative exponent, and then here it's negative 1 over 3 times y, and then this is x to the exponent of 3 over 3, right? And we add these exponents, exponents together, so 3 plus 1 is going to be 4, so it's going to be x to the exponent of 4 over 3 in the denominator, and then this is 7 over 3 times x squared. X squared is the same as x to the exponent of 6 over 3, right? And then we have to, this is our x squared, and then we have to subtract the exponent for this one. We'll do that on the next step. So here it's x to the exponent of negative 1 over 3 times y prime minus 1 over 3 times y times x to the exponent of negative 4 over 3. I change it to negative exponents, right? And then here it's going to be 7 over 3 times, well, now we subtract the exponents. 6 over 3 minus 1 over 3 is just going to be 5 over 3, just like that. And then we got this, right? And let's see what will happen if we use the integrating factor of negative 1 over x to the exponent of 3. So let's consider the second case. So the second case is if I of x is equal to negative 1 over x to the exponent of 1 over 3. So in this case, what we would do the same thing. We multiply each of these terms by the integrating factor. So we are going to do that. So it's going to be, we just basically multiply all the terms. So same thing. So negative 1 over x to the exponent of 1 over 3 times y prime minus 1 over 3. I'm just going to copy this term first. Times y times negative 1 over, this is our integrating factor, right? So I multiplied this by the integrating factor, and this is my integrating factor, times what I had originally here, and then this is all going to be equal to 7 over 3x squared times our integrating factor for the second case. So second case and first case. So first case, well, we got this. Now second case, let's see what we get. So we will get here, if we simplify it, this is x to the exponent of 1 over 3 in the denominator, so it's just going to be negative x to the exponent of negative 1 over 3 times y prime minus, here let's combine the y's here, the x's, so we'll put the y first, and then, oh wait, there's a negative and a negative, so this is going to be positive, so let's do that. So these two will make the positive, and then we have the y, so I wrote that, and then we have 1 over 3 times our x here, right, times x to the exponent of 1 over 3. This x here is going to be 3 over 3, right? 3 over 3, and then this is going to be, let's see, 7 over 3. This x squared is the same as x to the exponent of 6 over 3, so we can basically deal with it with x to the exponent of 1 over 3 here, right? This is negative, let's write the negative in front, this negative right here, and then we have times 1 over x to the exponent of 1 over 3. So we can subtract these exponents. So let's do that on the next step. So you can see it's kind of similar to the other one. So let's see what the differences are. So kind of take a guess what the difference is. So here, let's write the 1 over 3 in front times y, right? Y 1 over 3 and then y. Then this is going to be x to the exponent of 3 over 3 times 1 over 3. Well, it's going to be x to the exponent of 4 over 3 in the denominator, because 3 over 3 plus 1 over 3 is 4 over 3, right? And then here we have negative 7 over 3. 6 over 3 minus 1 over 3 is going to be 5 over 3. And then now we look at the next step. So we have negative x, negative 1 over 3 times y prime plus 1 over 3 y. This is going to be negative, right? Negative exponent. So we write that. So we kind of match up with this one. Show you in a minute why. And as you can see here, this is very similar to this one, to the first case. And that's because, well, everything's the same except here it's the negative, right? If you multiply this by negative 1, multiply this side by negative 1, you will get this. Because if we show it, we can show it this as negative, right? We can factor out this negative, factor out the negative, factor out the negative, so they become negative, right? And then we factor out this negative. Look, we factor out the negative. Hey, look, these negatives, if we multiply by negative 1 and multiply by negative 1 on this side, it's just going to cancel. And then what are we going to end up with, ultimately? We're going to end up with the exact same equation as this. So basically, this equation right here is the same as the one we found in the first case, which was this one. Okay, so what does this mean? Well, this tells us that both integrating factors, right, both cases, doesn't really make a difference which one we use to multiply. We end up ultimately with the same equation. So it doesn't matter, well, we have the absolute value, right? But we verified that with both of these cases, it still gives us the same equation. So we can just carry on from the equation. So let's just use this equation, right? Let's just work on it here. It's the same one as above, right? Because now it's without the negative. It's the exact same thing. So if you compare them, you see negative 1 over 3 here, y, x, negative 4 over 3. Like you can see they're exactly the same, okay? So let's just carry on from here and see what we do next. So here, let's rewrite this without the brackets so it looks a bit nicer. And then we see, oh, let's put the y by itself, because I do want to show you that there is something with this, and that is we can apply the product rule. So as you can see here, we can apply the product rule, right? Product rule for basically finding the derivative. So it's on the left side, if you haven't noticed, and this is because here, if let's say we find the derivative of this part, right, x to the exponent of negative 1 over 3, so if we find a derivative of this part, we will get negative 1 over 3 x, and then we have negative 1 over 3 here, right, and then we have to subtract 1, which is just 3 over 3, and then we will get x to the exponent of negative 4 over 3, right? We will get this, and this is the exact same as this part right here. This is the exact same as this part right here. So that means that, hey, well, this is a derivative of that. And then here, let's look at the y part. So if we were to find the derivative of this y, right? Find the derivative of that y, we will get dy over dx, which is just the same as y prime, hey, which is just the same as this, right? So this is a derivative of this, okay? And this is a derivative of this. So that would mean that we can take the original ones, right, these two, and we can multiply them together, kind of like undoing the product rule, because usually you use the product rule to differentiate. This time we're undoing it. Right, we have to find a derivative of this, right? This is a derivative. This is a derivative of what's inside the brackets. So that's going to be equal to 7 over 3 x to the exponent of 5 over 3. And then now what we do next is we can integrate both sides. So if we integrate both sides, we can easily solve this equation. So let's integrate this and dx like that. So now let's integrate this. So if you have a derivative and you integrate it, right, this is just going to cancel. So it's just going to be left with what we have in the brackets. So just this, right, because we cancel out the derivative with the integral. And then here, let's integrate this. So let's bring up 7 over 3. And then we have x to the exponent of 5 over 3 dx. And then what we have next is we have the following. We have to add 1 to this, right? 5 over 3 plus 1. 1 is the same as 3 over 3. So let's make a common denominator. And then here, the denominator is going to be the same thing. Okay, using the power rule for integration. And then we have to add c, okay, a constant c, because we got rid of our integral sign. So now we have the constant c. Okay, it's also from here too, as we integrate here. So it's just like a c that combines from both of them. And let's rewrite this nicely as y over x to the exponent of 1 over 3 using positive exponents. So here it's negative, so we'll put it in the denominator. And then we have 7 over 3, and then let's add these. So it's going to be x to the exponent of 8 over 3 over 8 over 3, like that. And then we will rewrite this, carrying on to the next step, and then 7 over 3 times x to the exponent of 8 over 3. This is 8 over 3, right? It's being divided, so we flip it. So it's going to be 3 over 8 instead, multiplied by this, right? This whole thing, and then plus c. These are all multiplications, putting in the brackets just to show clearly, right? It's the same as this, okay, and then separate from c. Now, our next step is we will simplify a bit more. Here we have 3 and 3. 3 and 3 cancel. Here it's 7 over 8. X to the exponent of 8 over 3 plus c, like that. And then from here, we will take this x to the exponent of 1 over 3, multiply it, right? Because we want to isolate for y. So we can isolate for this y. So it's going to be, we're going to multiply it by each of these terms. Multiply by x to the exponent of 1 over 3 plus c multiplied by x to the exponent of 1 over 3. And here we will get y is going to be equal to 7 over 8 to the exponent of 8 plus 1 here is going to be 9. It's over 3, right? So we can add because of common denominator. This is c, x to the exponent of 1 over 3. And then, hey, 9 over 3 is just basically 3, right? So we can just write 3 here, plus c times x to the exponent of 1 over 3. And finally, we have our equation, our y. And there we have it. We have basically solved the original equation, which was this one, right? We have solved this original equation for y, right? We solved this differential equation, and we used the linear differential equation method using this type of form, right? We basically changed all these into this type of format, right? And then we found the integrating factor and we multiplied both sides by the integrating factor. And so that's how we found our answer right here. Awesome, so great. Well, thank you for joining me in this video. And also, if you enjoyed this video, feel free to give it a big thumbs up. And also let me know in the comments down below what you think about these type of linear differential equations. And furthermore, if you are new to my channel and you love my content, feel free to hit that subscribe button. And as always, I love to know your thoughts on my videos. So thank you for joining me in this video, and I hope to see you next time for another one of my fun math videos. Bye guys!